Welcome to the session on the capacitors. The capacitor is the essential component of any circuit design. In fact, after the resistor, it is the second mostly used passive component in the circuits. The basic function of a capacitor is to store the electrical energy. In this video, let's understand how a capacitor works and how the energy is stored across the capacitor. It consists of two conductive plates which are separated by a dielectric material. This dielectric material is the insulating material which doesn't allow current to flow through it. When no voltage is applied, the two conducting plates of this capacitor are electrically neutral. It means that it has equal amount of positive as well as the negative charge on the plates. But once the voltage is applied to this capacitor, the electrons from the top plate tend to get attracted towards the positive terminal of the battery, and through the negative terminal, the electrons are pushed towards the bottom plate of this capacitor. Now, because of the dielectric material between the two plates, electrons which are collected at the bottom plate of this capacitor are not able to cross the barrier. Over the period of time, the electrons will get accumulated at the bottom plate of this capacitor, and the top plate will have a shortage of electrons. Or we can say that the top plate will get positively charged while the bottom plate will get negatively charged. It means the potential difference is developed across the two plates. Now, the building of charges across the two plates will continue until the potential difference that is developed across the two plates is equal to the supply voltage. Now, because of this potential difference, the electric field will get developed across the two plates, and the developed electric field is directly proportional to the potential difference, and it is inversely proportional to the distance between the two plates. Smaller the distance between the two plates, the stronger will be the electric field. So in this way, the capacitor stores the energy in the form of electric field. Now, even if we remove this voltage source, the charges that are developed across the two plates will remain as it is. Now, if a conductive path is connected between the two terminals of this capacitor and the load is in the form of the bulb, let's see what happens. When the switch is closed, the bulb glows as there is flow of electrons from the bottom plate which has excess of electrons towards the top plate which has excessive positive charge. This procedure continues till both the plates become electrically neutral. Now, the bulb is turned off as there will be no flow of electrons through this conductive path. In this way, the charge that was developed across the capacitor has been discharged through this conductive path. And this phenomenon can be known as the discharging of the capacitor. Now, what is capacitance? The ability of the capacitor to store the charge is known as the capacitance and is represented as the charge that is developed across the capacitor per unit voltage. Generally, it is denoted in terms of farad. Because this farad is very big unit, it is not actually used to define the capacitance. Rather, very small units like millifarads, microfarads, and picofarads are used to define the capacitance. Now, if you want to store more charge across this capacitor, you need to either take a capacitor of larger value, or for a given value of capacitor, you need to apply more voltage, which means by changing the applied voltage, we can change the amount of charge that is stored across the capacitor. But we cannot increase the voltage indefinitely. For every capacitor, you will find the maximum voltage rating defined. So, the voltage that is applied across the capacitor should be less than that maximum rating. If it is greater than the maximum rated voltage, dielectric breakdown occurs in the capacitor. Now, capacitance is given by the expression epsilon A by D. We can see that the capacitance of this capacitor is directly proportional to the area of the plate as well as the permittivity of the dielectric material, and it is inversely proportional to the distance between the plates. So, in the expression, it is clear that the capacitance can be varied by varying any of these three parameters. I hope the working of the capacitor is clear. Thank you. Have a great day.